All right, our second lesson for today is about modulus. So now that you've done some graphing of complex numbers, and you can look at a graph and be like, okay, the complex number is this. What's going on with this part is you have to get the modulus, which is just a fancy way of saying what's that distance from 0, 0? Yeah, it's just what's the distance of that complex number from the origin. And the way to do that is you figure out your complex number, a plus bi, and you're going to do a squared plus b squared, and then you square root it. Basically, what's going on, if you're looking at things graphically, is you're finding out how long this is. Well, to figure out how long it is, you can turn it into a right triangle. This is the a part, this is the b part, and you want to get the c part. Well, hopefully remember that a squared plus b squared equals c squared. If you do a little bit of square rooting here, you'll get the square root of a squared plus b squared equals c. And we could do plus or minus, but this distance is it's a distance, so you're going to just have the positive version. So that's where this is coming from. It's just right triangle, Pythagorean theorem stuff to get your distance here. And one bit of notation you do need to be aware of, if you want to write it mathematically to get the modulus, you just put two vertical lines around the complex number. So you could have -3 plus 4i, and if you do this, that means get the modulus, or how far that is from the origin. So that's a bit there. And something else you'll want to notice, that your modulus is always going to be, you always end up with a real number when you do that. And that's because you're going to square two numbers, and that's always going to end up being positive or 0. So you're never going to have a negative modulus on any of these. And so let's do some of these practice ones here. We get the modulus. Here's our a part, here's our b part. You don't put I in your equation here. So our modulus, modulus of 18 plus 24i is going to equal the square root of 18 squared plus 24 squared. And luckily I have my handy dandy calculator here. I got 18 squared plus 24 squared comes out to be 900. And I'm guessing the square root of 900 is a number. Oh yeah, it's 30. So it comes out to be 30. And there's my modulus. Hooray! 30. Problem over. Let's try a new one. Oh no, it's got a radical in it. You still do the same thing. Here's A, here's B. Once again, B does not include the I on it. But yeah, your modulus of 3 plus 3 root 3i is equal to the square root of 3 plus, 3 squared, plus 3 root 3 squared. You need to know how to deal with these. We've been dealing with them every now and then in this class, so make sure you're used to it. You end up with 9 plus 3 root 3 is 3 root 3 squared is 3 root 3 times 3 root 3, which the outside parts times together and the inside parts times together. You get 9 times square root of 9, and the square root of 9 is 3, so this is 9 times 3, which makes it 27, and so this is 9 plus 27, which comes out to be 36, conveniently enough. And then the square root of 36 is 6. Hooray! We found the modulus! It's 6. Hopefully I didn't botch any of that. And then our last one here, let's work through this one. The modulus of -2 minus 2i is going to be equal to the square root of -2 squared plus -2 squared. Right. A is -2, b is -2. You do want to put these in parentheses. If you're not putting them in parentheses, you're missing that important part of the order of operations. But this is going to come out to be 4 plus 4, which is the square root of 8. The square root of 8 can be simplified. 8 is just 4 times 2, and 4 is 2 times 2. So you can factor out 2 times 2. The square root of 2 times 2 is 2. So you get 2. And then you got this 2 left over inside here. So it becomes 2 root 2. And voila, we have our lovely modulus there. This does have a decimal approximation if for some reason you needed to get that. Alright, 2 times the square root of 2 comes out to be about 2.83, right? It's 8 to 8, keeps going. But there you go. So that's your lesson on modulus. Let's actually have you try out one of these all by yourself. Let's have you go to 5. So this one is here graphically. And you do need to figure out where your complex number is, and then you can get your modulus. Go ahead and pause the video for a couple moments and work through and get your modulus here, and we'll have you check it. Alright, let's see how things went. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 minus 1, 2, 3, 5, minus 5i. And so my modulus is going to be the square root of 8 squared plus negative 5 squared, which is going to be the square root of 64 plus 25. Let's see, 64 plus 25 is 89, so it's the square root of 89, which, is that prime? It's probably prime. Yeah, the square root of that does not come out to be a nice number. It's approximately 9.43. But yeah, so there's our exact answer. The distance is the square root of 89. So if you got that, congratulations there. If you didn't, you had to go back and check some things. Or maybe I totally got it wrong. You should let me know in an email if that's what happened. But yeah, there you go. Getting modulus. Pretty quick, pretty easy.